We will be talking about straight chain alkanes and common alkyl groups. We are
Kayla Cash
and Abia Usman. Well, first of all, what are straight chain alkanes? Alkanes are hydrocarbons. That means they only contain carbon and hydrogen atoms. A single covalent bond is what joins one carbon atom to another carbon atom. And the name of an alkane, which is what we'll get to in later slides, is made up of two parts. So the first part is going to be the prefix, which is composed of the stem, which is meth, prop, eth, and we'll discuss the later 7 in the next 2 slides. And then the suffix ends with ane, or A-N-E.
In this slide, we will show examples of straight-chain alkanes. The first alkane we will discuss is methane, which contains one carbon, hence the prefix meth. And the second hydrocarbon we will discuss is ethane. It contains 2 carbons, and the prefix for 2 carbon straight chains is eth. The third straight-chain alkane we will discuss is propane. Propane contains 3 carbons, and the prefix for 3 carbon straight-chain alkanes is prop. In this slide, we will also continue discussing the most common straight-chain alkanes. We will pick up with butane, which contains 4 carbons, and the prefix for 4 carbon straight-chain alkanes is bute. Pentane contains 5 carbons. The prefix for 5 carbon straight-chain alkanes is pent. Hexane has 6 carbons, and the prefix for 6 carbon straight-chain alkanes is hex. In heptane, we have 7 carbons, and the prefix for 7 carbon straight-chain alkanes is hept.
So for a closer look at these 4. So continuing with these examples, 8 carbons would be octane with the prefix oct. And then 9 carbons would be called nonane with the prefix non.
The last most common straight-chain alkane is decane. Decane contains 10 carbons, and the prefix for 10 carbon straight chains is dec.
So this is a table of all the prefixes that we went over in the past 3 slides, and these same prefixes are used for the alkyl groups. So, for example, for an alkyl group with 2 carbon atoms, the prefix is still eth, but instead of an ending with ane, it ends in a yl and is called ethyl. Now we're going to put all these tools together. We're going to name it. First, we're going to find the longest chain of carbons. Now at first, this seems very simple, but it can be tricky sometimes when the carbon chains are not all linearly aligned. We are going to do some examples of this in the following slides. For the second part, you have to number them to get the lowest first branch. So you assign numbers to each substituent or the alkyl groups attached, such as methyl or propyl. If 2 are on the same carbon, then they have the exact same number. Finally, we're going to write the entire name as a single word. There are no capitals. The substituents are in alphabetical order, such as ethyl would be before methyl in the name. Now we're going to do some examples.
Now we will try to name the first example. As you see, there are 4 carbons located in this chain. Since there are 4 carbons, the prefix will be bute. And since it's an alkane, we know the suffix will be ane. Now we have to label the substituent. From looking at it, it looks like it should be 3-methylbutane. But as the rule stated, we must get the lowest number on the substituent. Unlike reading, we don't always go from left to right when naming alkanes. The name of this alkane will be 2-methylbutane.
Now we are on the second example. As you'll see in this example, there are two substituents, both methyl groups, located here and here. This is a hexane because there are 1, 2, 3, 4, 5, 6 carbons. So we already know the ending is going to be hexane, and because there are two substituent groups, we are going to number them to get the lowest name. So if we number from left to right, we get 1, 2, 3, 4, 5, 6. And because there are two of them, we write 2, 3 dimethyl to indicate where the methyls are located. In the third example, as you can see, it's an octane because there are 8 carbons in the straight chain alkane. Next, we're going to look at the substituent groups. This is a methyl because there's only 1 carbon, and this is an ethyl group because there are 2 carbons. So now when we go to naming, these two substituent groups are going to be arranged alphabetically. After we number them and find out where they are located, 3, 4, 5, 6, 7, 8, we see that the methyl group is located at the 2nd carbon, and the ethyl group is located at the 5th carbon. However, the numbers do not matter, and we arrange them alphabetically. So it is 5-ethyl 2-methyl octane.
In our fourth example, at first glance, this may look like a hexane. But as we stated before, we must locate the longest carbon chain in the alkane. Here is the longest carbon chain located in this alkane. When naming, we will say that this is 4-ethyl octane because there is an ethyl group located on the 4th carbon.
Alkanes can be presented in various different forms. In examples 5 and 6, we'll look at cycloalkanes, where the carbons are connected to each other in a closed form. So the example in number 5 is cyclobutane because there's 1, 2, 3, 4 carbons, all arranged together.
In our last example, this is called cyclohexane because there are 1, 2, 3, 4, 5, 6 carbons enclosed in a loop.